Definite integration can be used to work out the area under a curve or a line. Here are 4 different diagrams that I've chosen from exam papers to illustrate different types of areas that we need to calculate. In this first one, we can see we've got an area under a curve between the points A and B, and the area under a straight line between the point 0, the origin, and A. So here, if I split this into 2 shapes, I can find the area under the curve between the x ordinate of A and the x ordinate of B, and the area of the triangle between 0 and the x ordinate of A, and then add those together. In this one down here, we notice that some of the area is positive because it's above the x-axis, and then this area will be negative because it's below the x-axis. Here, we must treat the 2 areas separately and find the sum of the positive value of these areas. So we need this area between A and B, and this area between B and C, which will be a negative value, and then add the positive value of each of those. We cannot do it as one integral from A to C because it would give us the area of A to B minus the positive value of this area B to C. In this example here, we have the area under the curve, so this triangle here, minus the area under the curve. And in this final diagram here, we have the area under the curve minus the area under the line. So if we drop 2 lines here and here, we can see that this shape will be a rectangle. So to get the shaded area, it's the area under the curve minus the area under the line. It's important to visualize the areas that you need to calculate before you do the calculation. Here we're asked to find the area of the shaded region. We've got the equation of the curve, y equals x squared plus 2, and the equation of the straight line is y equals 3x. Now we need to know these points here, the x value of A and the x value of B. So to do that, we can first solve these 2 simultaneously to get the points of intersection. So from this, we can see that the x value here is 1 and the x value here is 2. It's maybe also useful to work out what the value of the A coordinate is here so that we can work out the area of this triangle. So A is when x is 1, and the y value can be found by substituting into here to get 3. So now we know from earlier that this is the sum of, this area is the sum of the triangle plus the area under the curve between 1 and 2. Let's work these out now. So here I have the answer for the area under the curve is 13/3. I need to add that to the area of the triangle to get the shaded area. But before I do that, I can check my answer to the integral by typing in the calculator using this button here. So I've got x squared plus 2, and I'm going from 1 to 2, and it shows me the answer is 13/3. So I'm happy with that answer. Let's go back to this area. So the shaded area, it's the area under the curve, 13/3, plus the area of the triangle. So final answer is 35/6. And that's in square units. Here, as mentioned previously, the areas that we want go above the x-axis, so this area will be positive, and below the x-axis, so this area will be negative. We therefore need to find this area above the x-axis and this area below the x-axis separately and find the sum of the positive values of those areas. Let's look at A and B first. This is where the curve intersects the x-axis, so when y equals 0. Let's find the values of A and B by solving this to equal 0. So these 2 points are where A and B lie. So A must be at -2 because it's to the left of the origin, and B must be at 2. And we already know that C has an x coordinate of 3. So now we can find the sum of these 2 areas by doing each one separately. Let's do A to B first. So here we have the area under the curve between A and B. And it makes sense that these 2 values are equal because the graph is symmetrical about the y-axis. So let's work out this area here, and we're expecting it to be negative, and we'll use the positive value of that and add it to this area to get our final answer. So now we have the 2 areas. The area between A and B under the curve is 32/3, and the area between B and C, between the curve and the x-axis, is -7/3. So we're going to use this as the positive value, 7/3, and add it to 32/3 to get our final answer. So the final answer is 39/3, which is 13 units squared. Here are 2 questions for you to try. You need to find the area of the shaded region. This one on the left, it's the area that's trapped between this line here and the points P and Q. Underneath that line to this curve here, which has the equation y equals 16 minus x squared. In this one on the right hand side, the shaded region there is trapped between the curve, which is y equals 5 plus 4x minus x squared, and the line here, which is y equals 8. So pause the video, have a go at each question, and then press play when you're ready for the answers. So for this area here, we have an answer of 64/3 square units. So firstly, I've calculated the x values of these coordinates here, A and B. And it tells me that A is at 1. And B is at 3. So now I can evaluate this area here by doing the area under the curve between 1 and 3 minus the area of this rectangle here. So here we have the area of the rectangle, 2 multiplied by 8, which is 16, and then the area under the curve is equal to 52/3. So we need to do the area under the curve minus the area of the rectangle to get the shaded area. So the area of this shaded bit here is 4/3 square units.